Hope everyone's doing well. This particular video is going to introduce you to limits involving infinity and kind of how we can redefine or rethink about asymptotes. So I want to kind of illustrate this through one particular function at first, and I want to think about this guy, the rational function x plus 3 over x squared minus 9. Okay. Now before we graph it on the calculator, just understand a couple things. Okay. Number one, there's two PODs, right? There are 2 points at which this function doesn't exist. Therefore, those are 2 points of discontinuity. Okay, one is at x equals 3, and one is at x equals negative 3. Okay, both because f of 3 doesn't exist, right? And you know what? F of negative 3 doesn't exist, right? Because we can't plug those guys into the denominator, x value. Okay, so those are 2 points of discontinuity. The question is, what type are they, and what's the behavior of those functions around, of that function around those 2 points of discontinuity? So to think about what's happening around those 2 points, I want to think about the limit as x is approaching 3 of that function, I'll just call it f, and the limit as x is approaching negative 3 of that same function. Okay? I know they're both points of discontinuity, right, but I want to think about what kind they are. So what I'm going to do to evaluate the limit is to use, as we usually do, the quote-unquote equivalent form. Now it's not exactly equivalent, but it's almost equivalent. And that's this guy right here, right? 1 over quantity x minus 3. Okay? And so to evaluate the limit as x is going to negative 3, right, what I'm going to do is I'm just going to plug in a negative 3 in for the x value. Right, and I'm going to get negative 1/6. So that's interesting, right? Because now I know, since the limit as x is going to negative 3 exists, I know that x equals negative 3 is a whole. It's removable since the limit exists, right? But note that I still can't plug in 3 here, right? And what we're going to find is that limit doesn't exist, but it's a little bit more than that. So what I want you to do is to kind of consider this guy right here. The limit as x is going to 3. And let's take a look at our calculator and see what's going on. Okay, so I'm going to graph this guy up and kind of see what's happening at 3. Oh, come on, baby. There we go. And I already did graph it because this is the 3rd time I've made this silly video. And here we go. There's my rational function, the quantity x plus 3 divided by the quantity x squared minus 9. Okay, here's our graph. And what's happening here as x is approaching 3? Well, I'm going to approach 3 from the left. Okay, and what's going to happen is our y value is going to start heading southbound. Okay, in fact, the left-hand limit as x is going to 3 is infinity. Okay, negative infinity, excuse me. Okay, from the right of 3, right, the right-hand limit, x is going to approach 3 from the right, and I'm going to shoot up towards positive infinity. Let me try to get over there with the tracer. There we go. Okay, so now I'm at the right of 3, and I'm moving towards 3 from the right, and we can see that y is going to shoot up infinitely. So what's happening here at 3 is twofold. Number one, the limit does not exist. Okay, but it's a little bit more than that. Okay, so this guy does not exist. Okay, the limit as x is going to 3. Okay, but it's a little bit more than that. What's happening is, as x is approaching 3, right, for that function, we have really a plus or minus infinity. Okay, oops, let me write that properly. Okay, so to kind of redraw that graph, here's 3, the vertical asymptote. Okay, and what's happening to our function as we're getting close to 3 is, from the left, oops, excuse me, other way around. From the left, we're going down. Okay, so our left-hand limit is negative infinity, but yet from the right of 3, our limit is positive infinity. Okay, so what that describes is a vertical asymptote. That describes the behavior of a vertical asymptote. So since the function is heading towards either infinity from the right or negative infinity from the left, as x is approaching 3, that means, therefore, that x equals 3 is a vertical asymptote. Okay? And in general, this is how we can think of asymptotes in general. As long as the limit as x is approaching, we'll say a, is equal to plus or minus infinity, and it can be positive infinity from the right and left, positive negative infinity from the right, from the left, etc. So any combination of positive negative infinity from the left or right, then we have a vertical asymptote, not necessarily x equals 3, but for the generalized case, x equals a. Okay? So this is what it means to be a vertical asymptote. This is how functions behave around vertical asymptote values. Okay? Now I'm going to give you another example. So we're going to move along here. And I'm going to open this guy up. And I'm going to graph our old friend sine x over x. Okay? So sine of x over x. And I'm going to make sure I'm in the right mode. I am. I'm going to zoom trig it just to go from negative 2 pi to 2 pi on the x-axis. And here's sine of x over x. Okay? So here's my second example. Let's examine y equals sine x over x. And again, we'll see another limit as x is going to a limit involving infinity, excuse me, here. Okay? Now remember, there's a hole here. There's a hole here at 0, what would be 1, right? The limit as x is going to 0, we've talked many times, is 1. Okay? But that's not really relevant for this particular investigation. What I would like to consider are these particular limits. Okay? What's happening to our function as x is going to infinity? Or what's happening to that same function as x is going to negative infinity? Okay? Right? So again, we have an infinite limit somehow as x is going to infinity or negative infinity. And we're going to see what we can conclude. Okay? So what I'm going to do is I'm going to set up the table for sine x over x. Okay, I'm going to start maybe at 10. I'm going to go up in increments of 10. I'm going to see what sine x over x is doing, okay, as x is getting bigger and bigger. And it's not very big jumps, right? So here we can see x heading towards infinity, right? So we're at 100, x is at 130. And what does our y value appear to be doing? What one number do you think it's heading towards? If you said 0, that's correct. Okay. So the limit as x is going to infinity, sine x over x is 0. Okay. If you don't believe that, we can look at the graph, and I can just trace it, right? And if I trace it, what's going to happen is these oscillations about the x-axis are going to get tighter and tighter and tighter and tighter. So what happens with sine x over x? Way down here. So here's like 1,000,000. Ooh. Right? We kind of have tighter and tighter and tighter and tighter oscillations about y equals 0. Right? We have this pinching of sorts. Okay? And you know what? Isn't that a horizontal asymptote? Sure is. Okay? Sure is a horizontal asymptote. In fact, we have the same behavior as x is going to negative infinity, right? Way down here on the x-axis, right? We have a tighter and tighter and tighter and tighter pinching about y equals 0. Okay? So the limit as x is going to negative infinity is also 0, right? Okay, we can kind of see that here, or I can zoom out and we can see that as well. Excuse me, let's change the window to, let's go negative 100 to 100. And let's make the change on 20. Okay, and you can see how it's so darn, oh, that's too tight. It's too tight. Sorry about that, bad window. It's too tight here. So it kind of oscillates a little bit and it gets so tight here you can barely see it. So maybe I can change the y-axis a little bit. And we'll make the, whoop. How about, we'll go from 1 to negative 1. I'm not sure that's going to change it much, but let's keep it at that. See if that works. Up. 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 Yeep. Okay, what I had is the y minimum needs to be -1. Sorry, that's +1. Okay, let's try again. See if we get a little better picture. And it's so, here we go. The oscillations are tight in here, and then they get really, really thin. So this function, sine x over x, is petering out to 0 as x is getting towards -infinity and as x is heading towards +infinity. Okay? So here's what we have. Okay? We have the description of a horizontal asymptote. And we have a horizontal asymptote at y equals c when the limit as x is going to either plus or minus infinity of the function equals c. Right? Right? Just like in the case of sine x over x, as x is going to infinity, right, we peter out towards 0. So therefore we have a horizontal asymptote, y equals 0. Okay, is our horizontal asymptote. Okay, so we now have, to summarize, two ways to think about limits, and not only that, but asymptotes. Okay, we have here's a summary. We have a vertical asymptote, x equals c, when the limit as x is going to plus c equals plus or minus infinity. We shoot up or shoot down around c. That's a vertical asymptote. And we have a horizontal asymptote, y equals c, when the limit as x is going to plus or minus infinity equals c. Okay? Note that both of these involve infinities, right? Therefore, we clump them together in limits involving infinities. Okay? See you tomorrow. Come with some good questions and come with some good notes.